Stop. Stop and start over. Oh, okay. Here we go. This is section 5.4. And this is dealing with the fundamental theorem of calculus. To start off, we have an integration problem with the boundaries of 0 to pi over 3 over the function 4 secant of x tangent x. So in order to do this problem, you have to have good knowledge of calculus and trig, because you'd have to know that the derivative of secant of x gives you this big chunk right here, secant x tangent of x. So the antiderivative of this is secant of x. You pull the 4 out, and then you get 4 secant of x with the boundaries of pi over 3 to 0. And then you plug these in, and you get 2 minus 1 multiplied by 4, and you get an answer of 4. Next problem, we have a graph. Okay, so the graph deals with a function of y minus x squared minus 4 of x. And this graph has an area in the positive and in the negative. So you're going to have to recognize that you're going to have to split the integration up into two parts, the positive part and the negative part, and then take the absolute value of the negative part. So for the interval of negative 2 to 0, you integrate from negative 2 to 0 of this function, x cubed minus 4x, and then you get this, 1 over 4x to the power of 4 minus 2x squared. With the boundaries, you solve, you get 4, and that's for that interval. So you have 4 for that interval. Over the interval of 0 to 2, you're going to put the same function in, x cubed minus 4x. You're going to solve again. You're going to get the same thing. You're just going to plug in different values. It's going to be 0 and 2. And then once you solve for that, you get negative 4 over the interval 0 to 2. And then the total area, remember, you have to take the absolute values of each because you want the total area. And if that was negative, it would turn out 0. So you add the two together and you get 8. For the next problem, we're taking the derivative of an integral. And you're going to take the derivative, well, for this problem, we have the integral of sine of x to cosine of x of t squared. And for this function, you're going to have to split it up into two parts to make it simple. And once you split it up into two parts, sine of x, in order to get it to the top, you're going to its property is going to become negative. So you're going to have to subtract the two from each other, and you get the new boundaries to be 0 to cosine of x of t squared minus 0 sine of x t squared, the derivative of that big chunk. Then, once you plug in the values into the integration, you get, once you take the derivative, you get cosine squared of x times negative sine x minus sine x squared times cosine of x. And then you simplify and combine like terms to get your answer. Alright, so for this problem, it's asking us to find the f of 4 if the integration from 0 to x of f of t equals x cosine pi of x. So to start off this problem, you set f of x equal to the derivative of the integral of 0 to x f of t, because that's basically, f of x basically equals this whole chunk right here. So now you're going to solve for this part. So you're going to take the derivative of x cosine pi of x, because they stated that the integral of that was that, so we basically have an answer to that, and we just plug it in here. Now you're going to take the derivative of x cosine pi of x. So once you take the derivative and you plug in the values, you get x times negative pi sine pi of x plus 1 times cosine pi of x. And then you go farther to solve, you get this. And then f of 4 equals negative 4 pi sine pi 4 pi plus cosine 4 of pi, which once you solve for all of this, you get 1.